इस लास्ट लेक्चर में हमने ऑलरेडी वेव ऑप्टिक्स के ऊपर के जो क्वेश्चंस है या थियोरेटिकल क्वेश्चंस थियोरी खत्म किया था। तो आज के लेक्चर में हम उसके ऊपर न्यूमेरिकल्स करने वाले हैं। तो उससे पहले हम थोड़े फॉर्मूलेज रिवाइज करके लेंगे फटाफट। व्हाट आर द फॉर्मूलेज फ्रॉम वेव ऑप्टिक्स। अभी देखो, सबसे पहले हमने ये देखा वेव ऑप्टिक्स के अंदर स्नेल्स लॉ जो है, रिफ्रैक्शन के अंदर स्नेल्स लॉ हम यूज कर सकते हैं, जो कि रिफ्रैक्टिव इंडेक्स ऑफ one medium with respect to another medium is always given by sine of angle of incidence upon sine of angle of refraction. Remember, so this is called as the Snell's law. Then we have the refractive index to be expressed as the another formula, that is 1 and 2 is equal to v1 upon v2, where v1 is the speed of light in the first medium and speed of light in the second medium is v2 here. Okay, so this is the third formula, 1 and 2, which is going to be equal to actually lambda 1 upon lambda 2. That is the ratio of wavelengths of light in two different media. One more formula is there for refractive index. That is the apparent depth, real depth upon apparent depth. Remember. So if suppose the two objects, one object is kept in a medium, then its real depth upon apparent depth can also be supposed to be the formula for finding the refractive index. One more thing you have to understand. See, when we discussed about the refraction of light according to the Huygens principle, तो उसमें हमने ये देखा था कि एक रे जो है, वेव फ्रंट जो है, इंसिडेंट वेव फ्रंट का विड्थ थोड़ा कम हुआ करता है। इस तरह से हमने ये देखा था। This is the width of incident wavefront we have seen. This is the incident wavefront actually, and the refracted wavefront is just like this. तो ये refracted wavefront होता है। और अगर हम बात करते हैं width की, तो ये हो गया incident wavefront का width, और ये होता है refracted wavefront का width। ठीक है, जिसको हम बोल सकते हैं यहाँ पे, if we just say this is the point A here, this is the point B, this is suppose C and this is D. तो उसमें हम देख सकते हैं आराम से कि द रिफ्रैक्टेड वेवफ्रंट का जो विड्थ है वो है CD और इंसिडेंट वेवफ्रंट का विड्थ कितना है AB, करेक्ट। तो इफ यू जस्ट वांट टू फाइंड आउट द रेशियो ऑफ द विड्थ्स, रेशियो ऑफ विड्थ मतलब क्या है यहाँ पे कि ये जो रेशियो ऑफ विड्थ होता है, तो वो अगर सपोज हमको पूछा गया न्यूमेरिकल के अंदर, क्योंकि उसके अंदर एक न्यूमेरिकल है इस टाइप का, ठीक है, रेशियो ऑफ विड्थ निकालना होगा हमको इसमें। So what do you mean by the ratio of width of incident to refracted? So that will actually be AB upon CD. Sometimes maybe that ratio of width of refracted beam to incident beam, ये भी पूछा जा सकता है, no doubt. In that case, it will be CD upon AB. Just उससे उल्टा, no doubt. But here, if we just try to find out AB upon CD here, then we can express it in terms of I and R. If we just divide by AC, both numerator as well as denominator, तो इसको AB को AC से अगर हम डिवाइड कर देते हैं और CD को भी अगर AC से डिवाइड कर देते हैं, तो हमको देखो यहाँ पे रेशियो क्या मिलेगा। जैसा कि हम जानते हैं, दिस इज इफ सपोज दिस एंगल ऑफ इंसिडेंस, यहाँ पे हम मार्क करेंगे। उसके लिए हमको नॉर्मल ड्रॉ करना जरूरी होगा। सपोज दिस इज द नॉर्मल, yes, okay, this is the normal. So the angle made by the incident ray with the normal is called as actually the angle of incidence. This is actually going to be the angle of incidence. And we already proved that this is also going to be the angle of incidence, no doubt. And here, this is going to be actually the angle of refraction. And we already proved in the theory that this one here is going to be actually the angle of refraction, no doubt. So इस ट्रायंगल के अंदर अगर हम देखेंगे ठीक से तो AB upon AC क्या बनता है, देखो ठीक से AB upon AC, AB is going to be the adjacent side of this I and AC is the hypotenuse, so AB upon AC happens to be actually cos of I, remember. So this cos I is going to be the numerator here, so this cos of I, and this CD upon AC. Yes, CD is the adjacent side of R and AC is again the hypotenuse of the triangle ADC. So we can just say this CD upon AC to be the cos of R in this way, and hence the ratio of width का फाइनल फॉर्मूला क्या हो गया हमारे पास, तो रेशियो ऑफ विड्थ के लिए हमारे पास फॉर्मूला आ गया जो कि cos of I, और वो भी रेशियो ऑफ विड्थ ऑफ इंसिडेंट टू रिफ्रैक्टेड विड्थ रिफ्रैक्टेड बीम, that will be cos of I upon cos of R, ये याद रखो ठीक से. So this is the ratio of width का formula. Yes. Then again, if suppose the number of waves are traveling in the same medium, then we can just say that their velocity remains constant, and hence the velocity remains constant, and hence nu1 into lambda1 is going to be same as nu2 into lambda2. Remember, even if there is third wave of frequency nu3, then its frequency nu3 into lambda3 will also be the constant. So the product of frequency and wavelength is always remains constant in this case whenever the number of waves are passing through a same medium, remember. And if suppose the wave just travels from one medium to another medium, then frequency remains constant. तो ये जो है इसका common value जो है वो velocity मिलने वाला है हमको, the velocity of light in that particular medium. Okay, but in case when the waves travel from one medium to another medium, the ratio of velocities v1 upon v2 is going to be same as the ratio of wavelengths, that is lambda1 upon lambda2. तो ये हमको यूज करना है. और ये भी बात याद रखो ठीक से कि रिफ्रैक्टिव इंडेक्स जो है, रिफ्रैक्टिव इंडेक्स जिसको हमने यहाँ पे n बोला हुआ है, so this actually depends on the wavelength also. So n depends on the wavelength in this way, 1 plus a, that is some constant, upon lambda square, plus here b upon, which is again a constant, upon lambda raised to 4, and plus again c, that is a constant again, into upon lambda raised to 6, and so on up to infinity like this. So this is going to be the relationship between the refractive index and wavelength of light, which has actually which is called as a Cauchy's formula, which is not there in your syllabus, but you must know it, you should remember it. Okay, तो ये हमको अच्छी तरह से याद रखना है. इसके अलावा इसके बाद आगे चल के हमने इस चैप्टर के अंदर देखा कि पोलराइजेशन. सो पोलराइजेशन के अंदर एक ही फॉर्मूला हमने देखा, दैट इज द ब्रूस्टर्स लॉ. तो ब्रूस्टर्स लॉ which tells us simply that the refractive index of the reflecting medium is always equal to the tan of polarizing angle, which is denoted by theta p. Remember, n is equal to tan theta p is called as the Brewster's law. But अभी इसमें एक बात तुमको 11th standard में से याद रखना जरूरी है कि critical angle is also related with the refractive index, and the formula is n is equal to 1 upon sine of IC, where IC stands for the critical angle actually. So this is the formula for critical angle, remember. And this is the critical angle also related with refractive index in this way, and angle of polarization also is related with the refractive index in this way. So using trigonometric relationships, we can just find out the relationship between theta p, that is angle of polarization, and this IC, that is the critical angle actually. Okay, ये हमको समझना है. ओके यस, उसके बाद हम देखते हैं पोलराइजेशन में ये एक ही फॉर्मूला है, बाकी कोई फॉर्मूला तो एक्चुअली मेरे ख्याल से है नहीं, जस्ट चेक। यस ठीक है, तो उसके बाद हमने डायरेक्ट देखा इंटरफेरेंस, इंटरफेरेंस एंड देन डिफ्रैक्शन। तो इंटरफेरेंस और डिफ्रैक्शन के अंदर जो फॉर्मूले हमने देखे तो वो तो ऑलरेडी अभी लेटेस्ट ही है वो। तो इंटरफेरेंस के अंदर सबसे पहले हमने क्या देखा कि द पाथ डिफरेंस बिटवीन द टू रेज must be equal to n lambda for bright point। तो ब्राइट पॉइंट के लिए पाथ डिफरेंस जो है वो n लैम्बडा के बराबर होना चाहिए, और पाथ डिफरेंस बिटवीन द टू वेव्स must be actually equal to n minus half lambda for the dark point। तो डार्क पॉइंट मिलने के लिए ये वाला पाथ डिफरेंस, इतना पाथ डिफरेंस होना चाहिए, तो ये हमने देखा। और पाथ डिफरेंस इन केस ऑफ यंग्स डबल स्लिट एक्सपेरिमेंट has been found out to be simply equal to, path difference is going to be equal to y into small d upon capital D। तो ये फॉर्मूला हमने एक्चुअली प्रूव किया पाथ डिफरेंस के लिए, और यूजिंग दिस ओनली वी कैन जस्ट फाइंड आउट द फेज डिफरेंस आल्सो। तो फेज डिफरेंस और पाथ डिफरेंस के बीच में क्या रिलेशनशिप है तो वो भी हमको पता होना चाहिए। पाथ या सपोज फेज डिफरेंस, if you want to find out the phase difference, then we can just get this as 2 pi by lambda into the path difference। remember, तो path difference को अगर हम 2 pi by lambda से अगर मल्टीप्लाई कर देते हैं तो ऑटोमेटिकली हमको क्या मिलता है, we get the phase difference between the two rays। so if we have given with the phase difference, we should be able to calculate the path difference, and if we have given with the path difference, we should be able to calculate the phase difference, no doubt। and in case of the interference, the table of resultant has to be remembered। so this table is very similar to the table already we have drawn it in the oscillations, or even in case of the superposition of waves। ये टेबल बिल्कुल सेम है जो हमने ऑलरेडी ड्रॉ किया है। So in this case, depending upon the phase difference between the two waves, तो phase difference अगर suppose phi है, तो accordingly path difference will be denoted by delta here, and depending upon the path difference and phase difference, we can just be able to find out the resultant amplitude of the waves, R we can say, and also we can find out the resultant intensity, I we can say, okay। Because in general, what is the formula for resultant amplitude in case of the interference of two waves of amplitudes A1 and A2 respectively? So R is given by root of A1 square plus A2 square plus 2 A1 A2 into cos of phi, where phi is going to be actually the phase difference between the two waves, right? And hence, and the intensity of the resultant wave, IR we can say, is given by the formula I1 plus I2 plus 2 root I1 I2 again into cos phi। So this is the formula for finding the resultant intensity of the in case of interference pattern, okay। But अगर हम suppose हम ये case use करेंगे, if A1 is equal to A2, and we can just call it as A, and I1 is going to be equal to I2, and we can just call it as I here, okay। I इसको हम बोल देंगे, and actually I is going to be equal proportional to A square here। Okay, so I is proportional to A square in this way, yes। So in this case, I max and I min can also be found out। So if you just try to find out R max, then R max can be found out to be simply equal to A1 plus A2, which is equal to 2A in case when the amplitudes are equal. अगर ये केस है तो फिर वो 2A बन जाता है. Okay, and R min जो है मतलब minimum amplitude in case of interference pattern happens to be actually A1 minus A2. Obviously mod of this A1 minus A2 because we don't know whichever is greater, and that will be actually equal to 0 in case when the two amplitudes are equal. And maximum intensity I max we can say actually it is proportional to A1 plus A2 का whole square. Okay, A1 plus A2 के whole square के साथ वो proportion में होता है. And in case when A1 and A2 are equal, so in that case this I max is proportional to actually 4A square, because A1 plus A2 will be 2A and 2A का whole square अगर करेंगे तो ये 4A square हमको मिल जाएगा, जिसको ही हम 4 times of I बोल सकते हैं. So maximum intensity in case of interference pattern will actually be equal to 4 times of intensity of any one of these beams in interfering beams. So I max is going to be equal to 4 times of I, we can say. Okay, और दूसरी बात I min के बारे में अगर बात करते हैं तो the minimum intensity in case of interference pattern is always proportional to, not equal to, it's proportional to A1 minus A2 and the whole square, remember, and it will be 0 in case when A1 is equal to A2, no doubt. Okay, so if we just find out the intensity and resultant amplitude in all these 5 cases here, in which the phase difference between the two waves may be, first of all, we can just consider it as 0. In the second case, we can consider it as 60 degree. Then we can consider it as 90 degree. Then it will be 120 degree and 180 degree. तो ये 5 cases जो है वो हमको अच्छी तरह से याद रखने हैं. Okay, so in the first case, we can just have the phase difference to be simply 0. So path difference will also be 0. And in that case, R will be maximum, and that will be actually 2A here. And intensity will also be maximum, which will actually be equal to 4I here, remember. But on the other hand, if suppose the angle is 60 degree, phase difference between the two waves is 60 degree, that means pi by 3 radian, which is corresponding to the path difference. You can just find out by using this formula. तो अगर phase difference 60 मतलब pi by 3 radian है, तो pi cancel हो जाएगा, and path difference will become lambda by 6 actually. So this is lambda by 6. Okay, that is the path difference. In that case, the resultant amplitude of the two waves will happen to be √3 times of the amplitude of any one of the waves, and the intensity of resultant intensity at that point will be actually 3 times of intensity of any one of the interfering beam. And if the angle is 90 degree here, phase difference between the two waves is 90 degree, then in that case we get the path difference to be simply equal to lambda by 4 actually. तो ये lambda by 4 उसके साथ corresponding है, याद रखो ठीक से. And in that case, we can just get the resultant amplitude to be √2 times of A here. And at that time, the intensity will actually be 2 times of intensity of any one of the interfering waves here. And in case of 120 degree, if the phase difference between the two waves is 120 degree, then the path difference between them can be found out. 120 मतलब 2 pi by 3, right? So 2 pi gets cancelled, and we get this lambda by 4 here. So this lambda by 3 here is going to be the path difference, in which case the resultant amplitude happens to be simply A here, and resultant intensity happens to be simply I, that is the intensity of any one of the interfering waves, and final is 180 degree. If the angle phase difference between the two waves is 180 degree, that means the path difference between them is going to be lambda by 2 actually. In that case, we get the resultant amplitude to be 0 and resultant intensity also to be 0 simply. This is the case in which the resultant amplitude is going to be equal. The both of the waves are of equal amplitudes and hence the equal intensities. Equal intensities के waves मिल रहे हैं आपस में, तो उस केस में ये वाला पूरा टेबल हम यूज कर सकते हैं आराम से. But if suppose the amplitudes are not equal, then in that case we have to use these results which you have obtained here. I max is proportional to a1 plus a2 the whole square and I min is proportional to a1 minus a2 the whole square. And even उससे भी आगे जाके we can just find out the ratio of I max to I min in this case. So ratio of I max to I min can be written to be simply a1 plus a2 upon a1 minus a2 and the whole square like this. And in this way we can just get the maximum to minimum intensity ka ratio. Yes, but now we can just see the interference pattern. If you focus on the Young's double slit experiment, then in that case the bandwidth expression for bandwidth can be expressed as, so expression for bandwidth will be lambda into capital D upon small d. This is the expression for bandwidth, remember. And the interference pattern consists of alternate bright and dark bands in this way. The central band is always bright. Then after that, the dark, bright alternate bands are formed. If you just check their distances, तो देखो यहाँ पे, let us draw a simple diagram to show the band and bandwidth. वो डायग्राम अगर याद रख लेंगे ना, तो पूरा इंटरफेरेंस पैटर्न के अंदर के सारे फॉर्मूले जो है वो मोस्ट ऑफ फॉर्मूले तुमको लर्न हो जाएंगे. ये देखो, सपोज यहाँ पे okay. Suppose this is a vertical line and suppose central bright band जो है वो यहाँ पे हम रख देंगे. This is going to be the central bright band suppose. Okay. ये ब्लैक कलर से जो एक्सप्रेस किया हुआ है उसको हम ब्राइट कंसिडर करेंगे. ठीक है, ब्राइट. Then here this is the first bright band we can say. Okay, central bright band के बाद क्या आएगा? First bright band. Then it will be second bright band. Then again it will be third bright band. Fourth bright band. And so on up to like this. तो ये जो अलग-अलग bright bands है तो वो हम इस तरह से ड्रॉ कर सकते हैं. Even on the other side also, opposite direction में भी हमको सेम वैसे ही bright bands मिलते हैं. Remember that we are drawing only bright bands. Dark bands are not drawn yet. अभी तक हमने dark bands draw किए ही नहीं है. If you just want to draw the dark bands also, then we'll have to change the color. Red color से हम उसको draw करेंगे. और ये देखो ये वाला है first dark band we can say. This is going to be the first dark band. Again this will be the second dark band which is between second and first and second dark bright band actually. This is the third dark band we can say. तो ये जो red color से जो दिखाए हुए हैं वो actually dark bands है. Yes, in the same way here in the opposite side also, we can just draw them symmetrically. They are just equidistant. So between any two bright bands there is a dark band, and between any two dark bands there is a bright band. So this is the full diagram which you can just remember. And now we can just have the distances of all bright bands. If you just see the distance of bright band, so सबसे पहला जो distance है यहाँ पे, ये first bright band का distance from center obviously, हाँ सभी distances center से ही रहेंगे. तो ये जो first bright band का जो distance है वो होता है W, याद रखो ठीक से. This will be W. Yes, so this is going to be W. The distance of second bright band actually will be 2 times of W, we can say. So यहाँ पे ये 2 times of W आ जाएगा. देखो ठीक से. This will be 3 times of W. ये जो ब्लैक कलर से मैं ड्रॉ कर रहा हूँ, वो ब्लैक कलर से इसीलिए ड्रॉ कर रहा हूँ क्योंकि वो ब्राइट बैंड का डिस्टेंस है. ठीक है, ये 5 times of W. And similarly so on up to infinity. In this side also this will be W, means first bright band will always be at a distance of W from the central bright band. The second bright band will at a distance of 2W from the central bright band, and then so on up to 3W, 4W, and so on up to infinity. Okay, if we just talk about the dark bands, then we can just have these distances. The first dark band is at a distance of W by 2 from the center. Okay, so W by 2 हो गया second dark band, first dark band का distance. इस तरह से ये जो second dark band है उसका distance कितना होगा? We can just say that it will be 3W by 2. Remember, 3W by 2, no doubt. Then third dark band will be at a distance of 5W by 2 from the center, and so on like that up to infinity, like this. So this is going to be at 7W by 2, and similarly up to this 9W by 2, and so on up to infinity, like this. तो ये सारे जो dark bands है तो उनका जो distance है center से कितना रहने वाला है, तो इस तरह से हमको ये मिलने वाला है. याद रखो ठीक से. इवन इस तरफ भी हम देख सकते हैं. इसको अगर हम नेगेटिव बोलेंगे तो बेटर होगा, तो माइनस अगर साइन अटैच कर देंगे तो वी कैन जस्ट अंडरस्टैंड इन अ बेटर वे, बट जस्ट नॉट नीडेड एक्चुअली. सो दिस 3W by 2, अगेन दिस विल बी एट 5W by 2. ये जो रेड कलर से जो शो किए हुए हैं वो एक्चुअली डार्क बैंड्स है, याद रखो ठीक से. दिस विल बी एक्चुअली एट 7W by 2. ओके, ये इसका डिस्टेंस है, ये इसका डिस्टेंस हो गया, ये इसका हो गया, और ये इसका हो गया. इसका रहेगा 9W by 2, we can see. And this will be at a distance of 11W by 2, and like this. Okay, so ये सब जो distances है, अब देखो ये पूरा learn करने के लिए तो थोड़ा सा difficult है, but we can just learn 2 formulae in which all these distances are just covered. See, कौन से 2 formulae है वो? तो we can just say that distance of y nth bright band, okay, nth bright band will actually be simply n times of w. ये हमको याद रखना है, n times of w. मतलब nth bright band का distance कितना होगा? n times of w. ये देखो 2W, 3W, 4W, 5W, जो नंबर ब्राइट बैंड का होगा वही नंबर यहाँ पे हमको डालना है और उसके सामने W चिपका देना है, बस खत्म. And if you just talk about the dark band, then distance of dark band from nth dark band from the center will be actually YND on the screen, which will actually be equal to n minus half into W. This formula will just fit perfectly here. यहाँ पे ये perfectly ये formula fit हो जाएगा, चेक करके देख सकते हो. First dark band, which is this one here, will be at a distance which is obtained by putting n equal to 1 here. So n equal to 1 डाल देंगे तो 1 minus half क्या बनता है? Half बनता है, तो half W मतलब ही W by 2. that is going to be the distance of first dark band. Similarly, n equal to 2 can be put here so as to get the distance of this second dark band, which is 3 lambda 3w by 2 and so on like that. So the distance of all these nth dark bands can be obtained by using this formula on the screen. Remember, so these two formulae are just sufficient to find out the distance of nth bright or nth dark band from the center of this interference pattern on the screen here. ये बात याद रखो ठीक से. And using this formula, we can also find out the wavelength of light here. So wavelength of light जो है, so it can be found out to be W, that is the bandwidth, into small d upon capital D, where capital D is the distance between the slit and screen, and small d is going to be the distance between the two slits used in the interference pattern. And also that width जो है, bandwidth जो होता है, it depends on these three factors as we can see from the formula itself. तो लैम्बडा, कैपिटल डी और स्मॉल डी के ऊपर वो डिपेंड करते हैं. कभी कभी क्या करते हैं कि W जो है इट इज प्रोपोर्शनल टू लैम्बडा. तो इसके ऊपर क्वेश्चन तुमको इस तरह से पूछा जा सकता है कि इफ सपोज द वेवलेंथ if suppose by using blue light of wavelength suppose 4000 angstrom, the bandwidth obtained in the interference pattern is suppose for example 2.5 millimeter. Then if suppose the wavelength of light is increased to 8000 angstrom, that means it is doubled, right? Double हो गया wavelength. So what will be its effect on the bandwidth in that case? So it will also be doubled. तो ये हम समझ सकते हैं आराम से कि जो इफेक्ट वेवलेंथ के ऊपर होगा वही इफेक्ट यहाँ पे बैंडविड्थ के ऊपर होने वाला है, क्योंकि बैंडविड्थ एंड वेवलेंथ जस्ट आर प्रोपोर्शनल टू ईच अदर. इसका ही ऐसा कहने का मतलब ये हो गया कि W1 upon W2, that is bandwidth in the first case upon bandwidth in the second case, will actually be equal to the wavelength of light in the first case upon wavelength of light in the second case. अगर हमने wavelength ही चेंज कर दिया तो इस तरह से यहाँ पे जो wavelength का रेशियो होगा उसी प्रोपोर्शन में बैंडविड्थ बदलेगा. तो ये हमको समझना है. और उससे भी आगे जाके ये वेवलेंथ बदलने का जो दूसरा एक तरीका है तो वो ये है कि मीडियम बदल देना. अगर पूरा इंटरफेरेंस पैटर्न हमने किसी दूसरे मीडियम के अंदर अगर फॉर्म किया, if the whole experiment is just performed in another medium just like water, so in that case the wavelength will just get changed and the new wavelength can be found out by using this formula, that is the refractive index is always equal to lambda 1 upon lambda 2, correct here? So the new wavelength here, that is lambda 2 here, will actually be equal to lambda 1 upon mu, correct here? So in this way we can just get the new wavelength in this way, and once we get the ratio of wavelengths to be lambda 1 upon lambda 2 to be equal to refractive index here, then in that case we can just get that the ratio of wavelength is going to be same as the ratio of bandwidth also. So in that case we can just get that W1 upon W2 is actually going to be lambda 1 upon lambda 2, which is going to be same as mu here. Mu matlab refractive index, and or just we can just denote it by n as it is there in the textbook. तुम्हारे textbook के अंदर refractive index को n से denote किया हुआ है. So in that case we can just get that W1 upon W2 to be simply equal to n, and hence we can just find that the W2 matlab final bandwidth is actually 1 upon n times of the initial bandwidth here. That means bandwidth will also get reduced by a factor of n in this case. If suppose the whole interference pattern is immersed in another liquid like water, then its refractive index will be put here and the bandwidth will just get reduced by that factor of refractive index, no doubt. Second thing that is controlling the bandwidth here is this capital D, that is the distance between slit and screen. So if suppose screen is moved away from the slits, then D will increase, and if the screen is moved towards the eyepiece or towards the slits, then the capital D will decrease. But in short, क्या कुछ भी करेंगे, in any ways we can just say that this W is going to be proportional to D. तो D का अगर हमको initial final value दिया है, तो we should be able to find out the final value of W if initial value is given. That means we can just use that this formula W1 upon W2 is actually going to be same as capital D1 upon capital D2, where capital D1 and capital D2 are the initial and final values of D1 and D2. मतलब D के जो values है तो वो इस तरह से हमको मिलते हैं. और रही बात तीसरी जो कि W depends on this small d also, that is the distance between two slits, and it depends inversely on that. So which means that is W is going to be inversely proportional to 1 upon D, which actually means that the product of W and D is actually going to be constant. So इसका मतलब ये हुआ कि जो प्रोडक्ट है W into D ये हमेशा constant हुआ करता है, जिसका मतलब ये होता है कि if suppose we are changing the small d here, and if suppose we decrease this small d here, then W will just increase, and if the small d is increased, W will decrease, and the relationship between them will be W1 into small d1 will actually be same as W2 into small d2 in this way. So जिस proportion में हम इस small d को change करेंगे तो उसके उल्टे proportion में W change होगा इस तरह से. So this is the three cases in which this lambda or d or small d can be changed, and its effect can be observed on this W here. Sometimes both of them or all three of them can be changed. Okay. And one more thing here in case of the Young's double slit experiment is that whenever the whole if suppose the interference pattern जो है यहाँ पे, ये suppose interference pattern form हो रहा है, ये suppose दो slits है और यहाँ पे suppose screen रखा हुआ है, और ये दो होल्स है जिनमें से रेज पास हो रहे हैं, और यहाँ पे इंटरफेरेंस पैटर्न फॉर्म होने जा रहा है. सपोज एट दिस पॉइंट हियर मींस ये पूरे स्क्रीन के ऊपर इंटरफेरेंस पैटर्न फॉर्म हो रहा है, लेकिन अगर सपोज किसी भी एक पर्टिकुलर रीजन में या एक पर्टिकुलर रे के सामने, मतलब यहाँ पे इस पर्टिकुलर रे के सामने अगर हमने एक स्लैब डाल दिया, स्लैब जिसका थिकनेस T है, ओके, और जिसके मटेरियल का रिफ्रैक्टिव इंडेक्स जो है वो सपोज N है, तो उसकी वजह से क्या होगा, एक ऑप्टिकल पाथ डिफरेंस यहाँ पे क्रिएट होगा, और वो ऑप्टिकल पाथ डिफरेंस पूरे इंटरफेरेंस पैटर्न को जो कि यहाँ पे फॉर्म हो चुका है, अगर सपोज ये इंटरफेरेंस पैटर्न यहाँ पे फॉर्म हो चुका है और यहाँ से सपोज यहाँ तक फॉर्म हो चुका है, suppose the interference pattern is formed from this point to this point here in this on the screen here, then because of this introduction of this glass slab here in the path of one of the interfering waves, the whole interference pattern will just get shifted downwards like this. ये पूरा interference pattern जो है वो नीचे की तरफ shift होगा, and the distance through which it will just get shifted can also be found out. ये जो distance होता है यहाँ से लेके यहाँ तक, जिस डिस्टेंस से वो शिफ्ट हो गया, तो वो डिस्टेंस हम ढूंढ सकते हैं, उसको हम S से डिनोट करते हैं. You can just denote it by S, and that distance can actually be found out by a special formula. तो वो फॉर्मूला जो है वो हम यहाँ पे लिख सकते हैं. The shift of the interference pattern due to introduction of a slab of thickness T and refractive index N in front of any one of the interfering waves is given by T into N minus 1 into capital D upon small d, remember. So this is the formula for getting the shift. But if suppose we try to find out how many bright fringes or bright bands get fitted into this S distance here, तो इस S distance के अंदर कितने bands fit हो जाते हैं, वो अगर हमको निकालना है, which is called as the number of bright bands or number of bands that getting shifted, that can be found out by just dividing this S by W, where S is actually going to be T into N minus 1 into capital D upon small d. But already we have seen this W here, which is going to be equal to lambda into capital D upon small d. So in this case here, if we just cancel out this lambda, capital D and small d, then we'll just be left with the number of bands shifted to be simply equal to T into N minus 1 upon lambda. And this is going to be the formula for number of bands that is shifted. And this is the formula for the distance through which the whole interference pattern just gets shifted. Okay, in case of Young's double slit experiment. So these are all the formulae in case of Young's double slit experiment. And diffraction के जो formulae है वो actually हमने कल ही देखे थे, अगर ठीक से देखते हो तो diffraction के अंदर क्या क्या formulae है. सबसे पहले हमने देखा कि in case of diffraction pattern, the path difference between the two the waves, extreme waves, it is denoted by A into sine theta, or we can just call it as D into sine theta, no doubt. So this is the formula for path difference. Okay, but this path difference happens to be D sin theta होता है, लेकिन ये path difference के ऊपर condition क्या बनते हैं जो bright point के लिए और dark point के लिए. So if we just find out for dark point, तो dark के लिए क्या हमको condition मिलता है, तो condition मिलता है path difference must be actually equal to n, and bright के लिए मतलब ही maxima के लिए condition क्या हमको मिलता है, जो कि path difference must be actually equal to n plus half into lambda. Okay, तो ये हमको मिलता है. If you just try to draw the diagram, same diagram here in this case also, then we'll be able to understand this concept once again in a more better way. तो ये diffraction का diagram अभी हम draw करने वाले हैं, जिसमें सबसे center में हम draw करेंगे bright band. ये हो गया हमारा central bright band. उसके बाद ठीक है, bright जो है तो bright तो नहीं होते, लेकिन dark कैन ड्रॉ. तो यहाँ से सबसे पहला जो डार्क बैंड है तो वो हम यहाँ पे ड्रॉ कर सकते हैं इस तरह से. ये हो गया हमारा फर्स्ट डार्क बैंड. दिस इज गोइंग टू बी द सेकेंड डार्क बैंड. दिस इज द थर्ड डार्क बैंड, and so on like this on this one side. In other side also we can just get the symmetric bands. ये फर्स्ट डार्क बैंड, ये फिर सेकेंड डार्क बैंड, ये third dark band, and then fourth dark band, and so on like this in this way. Okay, but if you just see carefully, then there is a bright band between any two dark bands. But here we have to understand, if you just draw the bright band by black color, तो black color से हम यहाँ पे bright band draw कर रहे हैं, लेकिन यहाँ पे first dark bright band जो है वो यहाँ पे हमको मिलेगा. इसमें एक बात हमको समझनी है कि यहाँ पे कुछ भी नहीं होता है, नथिंग इज हियर. ओके, सो ये जो फर्स्ट सेंट्रल ब्राइट एंड फर्स्ट डार्क के बीच में कुछ भी नहीं है, तो ये हमको समझना है. दैट इज द बेसिक डिफरेंस बिटवीन डिफ्रैक्शन पैटर्न एंड इंटरफेरेंस पैटर्न हियर. दिस इज अगेन द सेकंड ब्राइट बैंड, वी कैन से दिस इज द थर्ड ब्राइट बैंड, एंड सो ऑन अप टू infinity in this side, and even in this side also. ये जो है ये सेंट्रल ब्राइट बैंड है, उसको हम थोड़ा और लंबा ड्रॉ करेंगे ताकि हम समझ सकते हैं. दिस इज द सेंट्रल ब्राइट बैंड which is different from all these. Here also in this side we can just have this first bright band. This is the first, the second bright band again. This is going to be the first, second, third bright band in this way. And if you just check out the distances, then if suppose we consider the distance of the first dark band to be W, ठीक है, तो ये जो W है तो यहाँ पे ये W इसका फर्स्ट डार्क बैंड का डिस्टेंस है, याद रखो से. This is W. Even we can just call this as W in this case. That is the distance of first dark band actually from the center, and this W is actually given by the formula, that is, see here, W is equal to lambda into capital D upon small d once again, where small d stands for the distance slit width in this case. So slit का एक ही single slit होता है यहाँ पे, तो उस single slit का जो width है तो उसको ही हम यहाँ पे W बोलते हैं. बिल्कुल. So in this case, if you just see, the second dark band happens to be at a distance of 2W from the center here. तो second dark band का distance कितना हो गया यहाँ पे? 2W हो गया. Similarly, 3W will be the distance of third dark band here in this case. 4W will be the distance of fourth dark band, and in the same way here in the opposite side also, this will be 2W, this will be 3W, and here it will be 4W, and so on like that. Okay, but if we just check out for the bright bands, then we can just say that the first bright band is at a distance of 3W by 2 distance from the center. See the difference. यहाँ पे फर्स्ट ब्राइट बैंड जो है वो कितना डिस्टेंस पे होता है, 3W by 2 डिस्टेंस पे होता है. ये सेकेंड डार्क ब्राइट बैंड जो है वो यहाँ पे 5W by 2 डिस्टेंस पे हुआ करता है. In the same way here, third bright band will get a distance of 7W by 2 from the center in this way. And here in this side also, the same thing will be repeated in this way. 3W by 2 for the first bright band, 5W by 2 for the distance of the second bright band, and this is the 7W by 2, which is the distance of third bright band from the center. So अभी यहाँ पे इसमें देखो डार्क बैंड है या ब्राइट बैंड है, जो भी ये डिस्टेंस हमको मिलता है तो वो डिस्टेंस हम दो फॉर्मूला से फिर से निकाल सकते हैं. देखो, फॉर्मूलाज फॉर फाइंडिंग द डिस्टेंस ऑफ डार्क बैंड. तो डिस्टेंस ऑफ dark band, that means nth dark band, we can just call it as YND here. So YND can be supposed to be n times of W, where W is going to be this lambda capital D upon small d, no doubt. And at the same time, the distance of nth bright band in case of diffraction pattern will actually be given by the formula n plus half. See the difference? There was n minus half in case of interference pattern. So n plus half into W. That's it. So this is the distance of nth bright band from the center. We can just check that this formula just fit perfectly here. And even the distance of nth dark band in this case can be given by NW in this way. And if you just try to find out the angular separation of this nth dark band, then we can call it as theta ND. So what is the formula for theta ND? It is going to be actually, yes, it is n times of lambda by D. Remember. Expression for the angle of bending for nth dark and bright band. So theta n भी उसको बोल सकते हैं. It will actually be equal to n plus half once again into lambda by D, 2D, lambda by D. That's it. All this formulae we have just seen in the last few lectures actually. Yes, and अभी suppose ये जो है ये तभी हम यूज करना है हमको कि जब थीटा का जो वैल्यू है it is very small. We have to use that with this when theta NB is going to be very small. Theta should be small enough for this to use. But if it is not, then in that case we have to use that this sine of this theta. Sine theta ND must actually be equal to n times of lambda upon small d. And here also, for using this formula, theta should be very small. अगर theta बहुत छोटा है तो ही हम ये use कर सकते हैं. But if it is not, then in that case, theta will just be replaced by sine theta. Sorry, ये नहीं. Actually, ये. Okay, this formula can be used only when theta is going to be very small. But if it is not, then in that case we have to use that sine of theta NB will actually be equal to n plus half into lambda by small d. but remember that in this case this small d here is the slit width. Okay, ये जो small d है वो actually slit का width हुआ करता है, जबकि small d in case of interference was the distance between the two slits. दो slits के बीच में का distance हुआ करता था वो वहाँ पे. That is also the basic difference between interference and diffraction, remember. Okay, so these are the formulae from this chapter. Formulas for ये जो हमने कल देखा था resolving power और limit of resolution, तो already हमने कल देखे ही थे. So let us study them as it is. So we will not discuss them here again. Already we have discussed them in the last lecture, so we can just start the numericals in the next lecture directly. Okay, one more thing is that if we want to find out the width of central maxima, then we have to add this w plus w and call it as 2w here in this case. This is the width of central maxima. Okay, so this is all about the today's lecture. We'll just stop here and continue the next part in the next lecture. Okay, thank you all of you.